Okay, how will you do this? Any idea?
minus 30. Okay, I have an equation, but it doesn't feel right. So 35x plus 60. So that's the first thing. So that would be the x being the time he needs to reach.
Mm-hmm.
So 35 miles per hour
Mm-hmm.
times x plus 60 will get the distance.
Mm-hmm.
Does that make sense? Or is
Yeah.
that wrong?
Wait.
Okay.
Let's see very carefully. This is airport. This is home. Right?
Okay.
One thing we know that distance is same all the time, whether he moves
Yeah.
fast or whether he moves slow. Right?
Yes.
So basically, let's suppose if he move with a normal speed. Let's suppose that time he was taking time t in hour.
Yes.
Right?
Yes.
So basically, in one case, what will happen? The distance will be equal to speed times time, right?
Yes. Speed 35 and then
And
um
35 times.
time
Now see, when he is moving with 35 miles per hour, he's
times.
taking t plus 1 hour.
Okay, yes, so that's what I did. Yeah. That's the equation I made. I did 35 times x plus 60, and instead of doing 1 hour, I counted in minutes
Okay,
just
okay, okay,
so
okay.
it's
So yeah, right. And
okay.
in second case, what happened when he was moving with, let's suppose he increased this speed by this thing. So that time speed become 50 miles per hour,
Oh, 50, yes, yes.
and that this will become t minus half because he reaches 30 minutes before.
But didn't he already go 35 miles already?
Yeah. See, when he is going with 30 miles per hour, that time he's taking 1 hour extra.
Yes, but like in the second case,
Yeah.
didn't he already go 35 miles before he started at that speed?
Hmm. Yes, yes.
So how can we factor that into the equation?
Okay, okay. So, for example, in that case, how can we do that? Oh, sorry, I just forgot that. He drives 30 miles in first hour. So, what you can see, for example, in that case, it will be basically 35 plus basically 50 times t minus 1.5.
How did we get 1.5?
1.5 means see, because I'm assuming, see, very just pay your full attention. Let's suppose just forget about, okay, just forget about 1 hour, okay, even if you forget about 1 hour, because in both the cases he is moving 35 miles, right?
Okay.
And let's suppose from here,
Oh, okay, that makes sense. That makes sense. That makes sense.
right, in the
Okay,
both the
got
case it's
it.
moving 35, right? From this point to this point he's accelerating basically, right?
Yes.
So can we say that in first case he is going to take 1 hour extra, and in other case he is going to take half hour early basically,
Yes, that makes sense. This makes sense. Okay,
right?
got
And
it.
yeah, and then you equate the equation, get the value of t, and substitute in equation, and then simply whatever the value you will get in this equation, just add 35 on it, and that will give you answer.
Okay, so we get 1710 equals um 15x, and then 1710 over 15. Wait, let's just calculate. 1710 over 15 is going to be 114. Okay, 114 is the 1 hour and 54 minutes is his desired time to reach. So if he's gonna be 1 hour late if he continues at this speed,
Mhm.
that means that doesn't add up. Wait, what? Uh,
Any issue in getting? Shall I explain again?
no. It's fine. I just and then distance, speed time equals distance. So speed would be 35 times 154 plus 60, which would be what? 254. Is the distance. 35 miles per hour, and then 254 over 60 would give us what? 35 times 254 over 60. That doesn't make sense.
Tell me where you getting stuck. Tell me, I will help you.
Okay, so the distance is equal to speed times time.
Yes.
So then our time is, so I solved for time, and I got that time is equal to 114. So
No.
1 hour.
No, that's wrong.
That's wrong. Okay.
Yeah. See, even okay, let's suppose even if you take in minutes, okay, let me take in minutes. Okay, so how can you take that? Because let's suppose this is going to be 35 plus t plus 60 equal to 50 into t minus basically 30,
Yes.
right?
Yes.
So that is going to be 35t plus 35 into 60 equal to basically 50t minus 50 into 30.
Yes.
If you take this side, this is going to be 15t equal to 35 into 60 plus 50 into 30.
Yes.
And if you divide 15 twice and 15 4 times.
Okay.
So
Wait. Oh, yeah. So you have 35. How did your 35? Okay. T 35 times 50 times 30, and then you had 35. Okay. That makes sense.
right, and this is going to be 140 and this is going to be 100. So t is basically how much? 240 minutes,
Okay, yes, makes sense.
right?
So that would be 4 hours.
Yeah, so
And then if you can be 1 hour late at 4 hours, so 35 miles per hour for 5 hours
yeah.
would be 35 times 5 would be 100 and
Yeah, and you also have to add 35 on it, right?
yes.
Because he has already traveled 35, you know?
Wait. Alright. So so T would be like the time he has to reach.
Yeah, from here to here. From this
And then-
this distance to this distance. But this much already he has traveled in 1 hour?
Yeah, so I'm just like counting that inside. So like I'm saying like he has to go in 4 hours, and if he continues, that will be 5 hours in total, and then 5 hours because I'm 5 hours over 35 because all I'm saying is like, so there's the time, and then he was gonna be 1 hour late from the time. It doesn't matter in the first hour how much he drives, because he drives at 35 miles an hour the entire way, I'm assuming, because I'm counting that he's gonna be 1 hour late. So then it takes him so then he just drives 35 times 5, or 35 times 35 times 5, because I'm just counting the total time, total number of hours times total speed, not counting from that time.
Okay.
Actually, no, you're right, because T is only from the home plus 35 to the airport.
Yes.
So then we have to add again 60. So that would be again 360. So if he
Ask me.
300 in total,
Mhm.
it's five. No, wait. 1 hour late, 360, 6 hours,
Mhm.
and then 6 times 35 would be 210.
Yo,
Okay.
got it?
Yes.
Yes. Easy or difficult?
That was easy. It was just a lot of like technicalities, I guess.
Mhm.
Or not technicalities, like a lot of like things you had to consider.
Yes.
Like the concept wasn't too hard, but like it's just like considering a lot of different things, right?
Yes, yes, yes.
Okay.
Perfect.
Okay.
Okay.
Okay. Susie pays for 4 muffins and 3 bananas. Calvin spends twice as much paying for 2 muffins and 16 bananas. Muffin is how many times more expensive than a banana? Okay. Oh, that's nice. So 2 in parentheses, 4x plus 3y is equal to 2x plus 16y. Therefore, 8x plus 6y equals 2x plus 16y. So 6x equals 10y. So muffin is how many times more expensive than a banana?
Mhm.
So what we're looking for is x equals blank y. So 10 over 6 equals 5 over 3.
Yes. Good.
Nice.
Perfect.
Okay. 6 regular hexagons surround a hexagon. Side length 1 as shown. What is the area of ABC? Okay. Given that they're regular hexagons, that means that that is going to be 120. Like, I can't point it out on your screen, but like
Mhm.
I'll just do it, and then so that's going to be 120 degrees.
Mhm.
And then two our side length 1, we cut it in half, we get a 30, 60, 90 once again, and then 1 second, this is hard to visualize.
Mhm.
So 30, 60, 90. So the long side is gonna be 1.
Mhm.
And then the short side is gonna be 1 over 2.
Mhm.
So then the middle, which we're looking for, is gonna be 1/2 root 3, and then that's only 1, so that's 2 root 3 is the side length of this triangle,
Mhm.
and then 2 root 3 is the side length, and root 3 is half the side length, and the whole entire, or no, root 3 is half the side length, and the entire triangle, it would be root 3 times root 3 is 3. So is it 3 root 3, B?
3 root 3. Let me check. What's the answer? Yeah, B. Good.
Okay. Okay.
Good, good, good. So these type of question, okay, these type of questions are there which you can expect in your these exams,
Okay.
right? So these type of questions, there is a lot of the probability, and I mean we will practice these kind of even advanced type of questions, right?
Okay.
Yeah, that will basically make things more easier to understand,
Okay, sounds good. Sounds good.
right? So I have also brought some papers from internet only. Okay, and
Okay, sounds
yes, so let's see MC10. For example, you have this problem. We will solve this problem today.
okay.
Hmm.
Several three-legged tables and four-legged tables have a total of 3 legs. If there is nothing more than one table of each type. Oh, if there's more than. Okay, that's not bad at all. So 3x plus 4y equals 23. And then how many three-legged tables do we have?
Hmm.
Okay. Sounds good. We only have one equation and 2 variables, so what can we do with this? We know that there's more than one table of each type. So then, if we know there's at least one table of each type, then 3x plus 4y, we can turn that into 16, because just remove 7 from that. Because 8, 11, 15 doesn't work. 4, okay, and then we're looking for how many y's and how many x's. So let's just start with 1 y. If there's 1 y, that's going to be 12, and 4 x's, and that works. So that means if there's going to be 5 three-legged tables and two let me just check that, and 5 three-legged tables and 2 four-legged tables. So E.
Yes. So they are asking what is the number of three-leg table? Yeah, 5. Good. Basically, right?
Yeah.
So it's basically that was simple actually. Based on that, you have to just do this, right? Okay.
Okay, bicycle travels at a constant speed of 9 miles per hour. Okay, yeah. A bicycle travels at a constant speed of 9 mph. Car starts 200 miles behind the bicycle and catches up in 4 hours. What is the average speed of the car in miles per hour? Okay. So, first of all, in 4 hours, the bicycle is going to travel 36 miles, and 236 is the total it needs to catch. 236 over 4 is going to be, let's see, 5, 23, 6, 59.
Yes.
It's a C.
Easy.
Yeah.
Right. Good. Okay, perfect.
Epic. So 12 1x1 squares form a rectangle as shown. What is the total area of the shaded regions? Okay, so how do we do this? We know that every triangle, if we can reflect it, becomes a quadrilateral. Does that help? I don't know. Does that help? And I really want to say that, like, each pair up or something to be 1, but we don't know that, which is somewhat hard. How do we do this?
Yeah.
Okay,
Tell me.
Okay. Okay. I
Look for triangle. Look for triangle instead of look for the triangle. 2 separate triangles.
2 separate triangles. Oh! I see.
Yeah.
Okay.
This one and this one.
So, I realized. Oh! I didn't see that. Yeah. Okay. So the 2 triangles, one has base 2, height 4, so that's gonna be 4 area. The other has base 4, height 3, so that's gonna be 6. 4 plus 6 is 10.
Simple,
okay.
Right?
Yeah. Yes.
That makes the problem much easier, right? You look for the option because they are Basically, they're checking the things. Okay, they're checking that how sharp you can think of the diagram.
Yeah, that's
Yeah,
cool. That's cool.
perfect.
The values of A, B, C, and D are 2, 3, 4, and 5, but not necessarily in that order. What is the maximum possible area value of A times B plus B times C times D times B? Okay, the first thing that we're going to realize right away is that B is multiplied the most times.
Mm-hmm.
So that means that we want to maximize the value of B. So we got A times 5
Mm-hmm.
plus 5 times C plus 5 times D.
Mm-hmm.
And then after that, it really doesn't matter what A, C, and D are because they just come up the same amount of times.
Mm-hmm.
So we can input 4, 3, 2 into there. So 4 is 20, 3 is 15, and 2 is 10, and we get 40.
Yes, exactly. Otherwise, you can take directly the things common. Let's suppose if you take B out, so it's going to be basically
Oh, yeah.
A plus C plus D, right?
Yes.
Yeah. So basically, when you add the things, that's going to be basically A plus C this thing. So if you take outside 5, because the number which you multiply higher, that's going to give you the largest value, right?
That makes
Yeah. So just simply add them, multiply by the 5. That's give you answer.
Okay, that makes sense. Yeah.
Right. So you need to look for this thing. Perfect. Let's take one more question on it.
Okay. There are 400 students at Einstein High School where the ratio of boys to girls is 3 to 2. When there are 600 students at Edison High School where the ratio of boys to girls is 2 to 3. Considering students from both schools, what is the ratio of boys to girls? Okay, not bad at all. Okay, so given that we have 5 total, 5 times 80 is going to be 400, and then 80 times 3 is going to be 240 boys. And then 600 students, 600 over 5 is 120, I believe. Yeah. And then a ratio of, so number of boys are going to also be 240. So 480 total. And then 400 plus 600 is 1,000. So that means there's 520 girls and 480 boys. Then we can simplify the ratio: 48 to 52, 24 to 26, 12 to 13.
Yes.
Wait, that's not. Oh yeah, it is. That's right.
Yes.
That makes sense.
Good. Okay. Question number 6.
The price of each item at Gauss Gadget store has been reduced 20% from its original price. A printer has a sale price of 112. What will the same printer? Oh, easy. Okay. 0.8x equals 112. 112 divided by 0.8 equals x. Multiply top and bottom by 1120 over 8 equals the original sale price. 1120 over 8, 1120. 140. 140 is the original price. So 0.7 times 140. Oh, that's funny because 7 times 2 is 14. Okay, 0.7, so it's gonna be, 0.7, 7 over 10 times 140. Yeah, let's just do it that way. 14 times 7 is gonna be 98.
Which one? 98?
Yes.
Good. You're quite good actually. Okay, we need to just brush on the more things, right? We have to increase the label actually of the question, right?
Yeah.
You are in.
I mean, I don't actually get that far in ants. Like, I don't do that well on the test actually. It's okay. How many ordered pairs satisfy x squared plus y squared is 50? Okay. Positive integers. Well, that's not very.
Mhm.
Okay. So I'm just gonna list out the squares because
Mhm.
I'm sure there's an algebraic way to solve this, but I just feel like this may be faster.
Yeah. Just take this guess process,
49. So 49 and 1 is one pair, so we got one pair.
Mhm.
4 doesn't go with anything, so we can cancel that out. 9 and what? 9 doesn't go with anything, does it? No. 16. No, this can't be. But you can add to itself, right? 25 and 25 adds, so that's 2. Then what? Positive integers. Oh, right, 0 squared. No, 0 isn't positive. 0 isn't positive. Think. 16 plus 4. No. 34. No. 41. Nope. XY positive integers. What am I missing? $49. Okay, what about ones after? 7. 64. X squared plus y squared equal to 50. X squared plus. I think. How many ordered pairs? Oh, I'm dumb. It's 4. It's 4B.
How? Which one?
So there's 2 pairs.
Mm-hmm.
There is 25 and 25. Oh no, it's 3. It's 3.
Yeah, it has to be 3, right? It's 1 and 7, 5 and 5, 7
Yeah.
and 1.
Yeah, I forgot that like you can reverse the order. So I was wondering like how could I find more? Yeah.
Yeah. Right?
Okay. Yes, that makes sense.
Good. Okay.
How many different ordered pairs A, B can be formed using set of integers such that A is smaller than B and A plus B is even? Okay, first let's figure out the second condition. Because any 2 integers we form, we can have A smaller than B.
Mm-hmm.
Because you just like change the order.
Mm-hmm.
So A plus B is even. So odd plus odd is even. And even plus even is even. Odd plus even is odd. Okay. So we just have to solve the parity. So first let's do case 1, where we choose 2 odd numbers. Between 1 and 30, there will be 15 odd numbers, right?
Mm-hmm.
So we're just going to do 15C2. 15C2 is 15 times 14 over 2 is going to be 7. 15 times 7 is what? 105. Okay, then let's do even, same exact thing, so 210.
Mm-hmm.
Is that the answer?
210.
Yeah.
Okay. How you did that? Just can you repeat? I couldn't understood.
Okay. So the first parameter was that A is smaller than B.
Mm-hmm.
So for any 2 numbers in this set,
Mm-hmm.
there will be 2 numbers, and we can organize them in whatever way such that A is smaller than B. But the only thing that tells us is that we cannot rearrange the pairs, and we don't multiply our answer by 2.
Mm-hmm.
Then we had to find the actual thing. So the parity to get even, you either do odd plus odd or even plus even.
Mhm.
Now there are 15 odd numbers. So we're doing case one in which we're doing odd plus odd. So there are 15 odd numbers in 1 to 30.
Yes.
So now how many ways can we choose two odd numbers in 1 to 30? That's 15 choose 2, and I got that is 105
Mhm.
because of yeah. And then the same thing, exact thing with even. There's 15 even numbers, and that's going to be 15 choose 2 again, which is 105 plus 105 is 210.
That's make you 210. Perfect.
Okay.
Good. Okay, let me take some difficult problem.
Okay.
Okay, let me take this one before we finish the class. Okay, let's take this one.
Okay, Mike wants to fill his swimming pool using 2 hoses, each of which sprays water at a constant rate. Whose X fills the pool in X hours when used by itself, where X is a positive integer. Whose Y fills it in Y hours when used by itself, where Y is a positive integer. Okay. Whose X and whose Y total fill the pool in 10 hours. How many possible values are there for Y? Sounds good. Okay. So when we have X hours when we use it by itself, and X is a positive integer. Okay. So, in 10 hours, and obviously you're gonna know that X is greater than 10 because when they're both working together, and we know they're positive integers. So X is gonna be greater than 10. So in 10 hours, whose X is going to fill 10 over X amount, and in 10 hours, whose Y will fill 10 over Y amount. And 10 over X plus 10 over Y is equal to 10. Or no. 10 over Y, X plus 10 over Y is equal to 1. Is equal to 1 because... Wait. Yeah, is equal to 1.
Okay.
Now we know that... Now, how many possible values of X and Y are there that make this value 1? Okay. So normally, I would think of this. I'd use the stars and bars method for this, and we would try to see how many ways can we divide many stars into two jars. But right here, the thing is that X, you'd have to multiply by since X and Y maybe aren't the same thing. If that means that
okay, see, how can you do? Okay, let's suppose for example this is filling in XR, right, and this is filling in YR.
Yes.
So what you can assume, let's suppose for example in 1 hour, let's suppose whatever the tank may be, in 1 hour it will be basically it will be doing this much 1 upon X.
Yes, so do 1 over X.
Right, and the second will be doing 1 over Y.
Yes.
And that is going to be 1 over 10 basically.
Oh yes, that makes sense. Yes, 1 over X plus 1. Yes. Okay.
Right, and from here you just simplify like that, right? So it's going to be xy plus x plus y equal to 10, and you find the equation, get the answer. Xy has to be 10 into x plus y.
Oh, wait. 1 second, 1 second. I'm just trying to figure this out. So,
right? Because if you just add that, that's going to be x,
what
y.
did we do? We multiply, how did you get xy over x plus y is 10?
See, simply solve this. Okay, let's see. 1 over x plus 1 over y equal to 1 over 10. If you take the LCM xy, it's going to be x.
Okay, so we did y plus x
Yeah, the same
over,
thing, right?
over what? Xy equals 1 over 10, and then you found the reciprocal, you did xy over x plus y equals 10. Okay, got it.
Yes. Right?
Got it.
Now you can see, right, that basically whatever the multiplication of x and y should be, that should be at least, it should be 2 into 5 at least, or it can be 1 into 5, 1 into 10. Right?
Oh, yeah. Wait. Can you just say that again, sir?
Okay. See, basically, let me write it again properly. So the equation becomes basically xy equal to 10 times x plus y. Right?
Yes.
Now now we need to choose the value. Basically, for example, for the multiplication of this. Right?
Yes.
Or you can say, or basically you can also say that xy upon 10. So x plus y. So x plus y should be taken in that order so that it should be divided by 10x. Right?
What do you mean by in that order? Like,
See,
so that it should
basically,
divide.
basically, what should happen? Let's suppose, for example, this is a positive number, right? This is a positive number,
Yeah.
and this is a positive number, right? And
Yes.
so when you multiply these two number by this thing, you should also get positive number.
Yes.
And over here they are saying that should be divided by 10 basically. Right?
Yes.
So we have to select the value which should be, whenever we are adding, that should be divided by 10.
Whenever we are adding, so some multiple of 10.
Or yeah, whatever you can say. That their
Okay.
the product should be multiple of 10,
Yes.
right?
Yes.
And then
Okay.
you can look for the possible values. This is, you have to think. Okay, this is quite good question.
Okay. Nice. Okay.
Think for it very carefully.
Okay. So, things that multiply to values of 10. So 20 works. 20 works.
Okay.
XY is 20. Well, X and Y are 20. What about 12 and 15? Let's see. 6, 2, 180, 10. You know, like about 20 times. No, we did. 2 times 25.
Getting something?
I got like one possibility, but I'm looking for other ones right
Okay, let me tell you about the hint about that. Okay, now see,
now.
basically, you have to think for that number. Okay, you have to think for that number when you multiply. Okay, let's suppose when you multiply, that should give at least 10 out of the bracket.
When you multiply, it should give at least 10. Okay.
Right? For example, let's suppose it can be 15 times 10. This can give you 10, right?
Yes.
So, but you need to be careful that, let's suppose this is 15 into 10 equal to 10 into x plus y, right? Or basically 15, this is going to be 25, and this is this, so 15 equal to 25. That's not going to give, right? But it should carry 10 actually, whenever you multiply it. It can be, let's suppose 5 into 2, that is one possibility like that, right?
But we know that it has to be greater than 10. So
Definitely, yeah. So it can be 12, it can be 15, right?
yes.
Like that.
Okay, got it. Okay. Okay. What about nope. Okay, what about and how do we know when to stop?
When to stop?
Yeah.
So for that stop, you can look for this option. Like x over y upon x plus y should be equal to 10. It should not be more than 10.
Okay. So the only one I've found right now is 20 and 20. So
Only 20 and 20.
yes.
Yeah, there are few more. You're close, but you have to look for that. Okay.
Okay.
Yeah. So
Yes.
just take the picture of this. Okay. And you send me the solution.
Okay, we'll do.
Okay. Otherwise,
Okay.
I will WhatsApp this question to you, and you have to think for the question. Then I'll explain you in next class. Okay.
Okay, thank you so much.
Yes. So I hope you enjoyed this lecture today, right?
Yes.
Definitely. Next class, I will bring you more difficult problems than we will do, right?
Okay.
And then I will tell you some shortcuts where you can think. It's very, very easy actually. I'll tell you the things, okay? I'll tell you about this. It's very easy actually. In 1 second, you can think of it. But you have to click you by yourself. Then I'll tell you.
For what?
No, I'm just saying that you can do this question within 1 minute actually.
Oh. Okay.
Okay, but I just want that you think and then you send me the solution.
Okay, I'll send you the solution for sure.
Perfect?
Yes.
Okay. Then for today you enjoy. Okay, then we will meet soon, right?
Okay, thank you.
Yeah, welcome. I need to go because I have next class right now. Okay?
Okay.
Yes. Okay, so nice meeting.
Nice meeting you. Bye.
Bye.